Okay, so let's continue the discussion from this slide. Now, if you remember, we had 2 points A and B, and from these 2 points, we can get the equation of the straight line connecting A and B, yeah? So the first thing is we need to get the value of the slope, and the value of the slope here is given by rise on run, or if you want to remember this one, that's the difference in y value and then divided by the difference of x values. And after that, we can calculate the y-intercept, yeah? So basically, we'll just choose one of these points here and then plug in this coordinate into this general equation. Now, I want to talk about the slope of a straight line. So as you see here, we get a positive value of a slope. And normally when we talk about the value of a slope, yeah, we can get the positive value like this. So basically what happens is the straight line that you will see will be something going to that direction. That's the positive slopes. Now, if we have negative value of the slope, yeah, so basically we will see the lines like this going to this direction. So these are the lines that have negative slopes. Okay, now if you remember the equation that we got here, y equals to half times x, yeah. Now I want to bring you to this website again, Desmos, and let's just plot what we got here. So basically, that's half times x. Here we go. So this is the line that we got before, yeah. See, this line is passing through this point 4, 2, and then also that point, yeah, 8, 4. So now let's suppose I have another linear equation similar to it, but this time I will add a value. So for example, I add 2. So you see now the blue line here. What happens here is actually from the previous line, the red one, we shifted the line vertically upward, yeah, so we shifted up 2 units. You see now this point from here to there, so basically it moves from 0 to 2. And you can also say you want to have y equals to half x and then minus 4, for example. Now you see the green line here. That's the line y equals to half x minus 4. Now I want to show you something very important here. Well, what happened here is, again, we just shifted the y-intercept value of this line, yeah. Initially it was at 0, y equals to 0. And then when you have y equals to half x plus 2, basically you move that point up 2 units. Or now when you have y equals to half x minus 4, basically you move that y-intercept point downward, yeah, 4 units, so it now is at y equals to minus 4. But you see, these lines, they have something in common. So these lines, they have the same value of the slope, the same value of the gradient, which is equal to half. So that's what happens actually when you have the lines that have the same gradients, the same slope. They will be parallel. They will be parallel like this, yeah? So again, when you consider, for example, this line, and this line, yeah, since they are parallel, therefore their slopes, yeah, M1, M2, and M3, they are the same. Okay. So this is the first important lesson that I want you guys to remember, to know about the slopes of the lines. Yeah. All right. Now, the second important thing is now, if I say I want to have another line, but for example, now I will write down the fourth one, which is something like this. Now, y equals to minus 2x. Yeah. So this line, the purple one, it's doing something very interesting. And like I said to you before, if you have a negative slope, this line will go into that direction. Yeah, this direction. So when you try to measure the angle between these two lines, yeah, y equals to half times x, and oops, the one before, y equals to minus 2x, yeah, when you try to measure the angle between these two lines, they are perpendicular one another, meaning that the angle between these two lines is 90 degrees. So you see, this is also another important thing that you need to know. When two lines are perpendicular one another, that means you see, okay, now if I look at the value of the slope here, the first one is half, yeah. So the second one is minus 2, right? Now, when two lines are perpendicular one another, therefore, when you look at the slope here, M1 and M2, and then when you try to multiply them, so this is what you will get, half times minus 2. So basically, when two lines are perpendicular one another, their product, their multiplication of the gradients equal to minus 1. So this is another important thing about slope. When you have two lines are perpendicular one another, therefore the first slope times the second one equals to minus 1, right? So now I want to show you also some other important lines. Yeah. For example, if I have now a line, for example, y equals to a value, so y equals to 5. Yeah. So you see, we have now a horizontal line. We have now a horizontal line. So what happened here is we also have a line that has a slope equal to 0. So because you know, when you write down this y equals to 5, it's like you have y equals to 0 times x plus 5, and this 0 here is your slope. Yeah. So you now see when the slope equal to 0, what you will see is a horizontal line like this one. Yeah. And there is one more important line here. So that's just a line. Yeah. You see, x equal to, for example, 5. Now, when you have this x equal to something, what you will have is a vertical line. So what happened here is actually, this is also a special line where the value of the slope is undefined. Yeah, undefined. so this is the line. Well, it looks like it's just a vertical line. Okay, so remember we have learned some important properties related to the slope. The first one is when you have two lines and they are parallel one another and the slope equal to m1 and m2, what happens is actually the value of the slope, they are equal. Now when they are perpendicular one another, that means the product of these slopes, the m1 times m2 equal to -1. And then you see the previous one was when you have a line y equal to something, for example, equal to k, yeah, that means you will have a horizontal line. And then the last one here is when you have x equal to a value, yeah, k, for example. Therefore, you will have a vertical line like this. Okay, now I want you to look at some of the example that I want to show you here. So basically, we will do some practices, yeah. Now, if I give you like the previous example, yeah. For example, now we have 2 points located on the Cartesian plane. For example, the first point here is at point P, and the coordinate is 1, -4. And the second one, we have point Q, where it's located at this coordinate. Now, the question is write down the equations of the line passing through P and Q. Right. So, okay. You see, if you try to plot these two lines here, these two points on the Cartesian plane. So the first point here, P, it's located. So this is, for example, the 1, and then, okay, -1, -2, -3, -4. Therefore, this is where P is located. And then the second point, it's at 2, 3. So this is 2 here. 1, 2, 3. Okay. So now when you connect these 2 points here, the P and Q, the line that you will get, it's something like this. Yep, something like that. So now when you want to get the equation of the line, yeah, actually from the previous example I gave you the general equation where y equals to the slope times the x value plus c, right? And then the way we do it is by first getting this value of slope. Basically, it's rise divided by run, or in this case, we can just write down the y of q minus the y of p divided by the x of q minus the x of p. So in this case, we'll just plug in this number, yeah, 3, and then minus 4 divided by now the x value of q is 2, and then minus the x value of p, which is 1. So as long as you put this number everything correctly, you'll be fine. Yeah. All right. Now what we will get is so the value of the slope here, it's equal to 7 divided by -1. Let me see. Oh, sorry, 7 divided by 1. So the slope is just equal to 7. And that's something we expect, because remember when I told you when you have a positive slope, the direction of the line is going to go that way, okay? So that's about the positive slope. Now, once you get the value of the slope, yeah, normally we will also now get this y-intercept by using one of these points. So for example, you use this Q, yeah, and then plug in the x and y value of that point into this equation. So in this case, 3 equals to 7 times x plus, 7 times 2, yeah, plus c. Okay, so here we go. 3 equals to 14 plus c, and then we got the value of c, which is minus 11, right? Minus 11. Therefore, the equation of the straight line for this line, y equals to 7, and then plus 7x, yeah, plus minus 11, or simply y equals to 7x minus 11. Okay. So there are actually some different ways to get the equation of the straight line. Yeah. Normally, when you have 2 points, yeah, you can get the slope first, and then after that, as you see from this example, you can plug in into this general equation to get the value of the y-intercept. But there is actually another general equation of the equation of the straight line. So this is called the slope point form. So the form is like this. It looks similar actually. So what happens is we have y minus y1 equals to m times x minus x1. So this general form is called the slope point form. Okay, and there are many other general form of the equation of straight line. Yeah. So I don't want to discuss all of them because basically they are the same thing. They will give you the same thing at the end. So I think this is the second one that I will discuss with you and show you how to use it. Okay. So what happened is actually after we got the value of the gradient, the slope here, we'll just simply put this value here, 7, and then, you know, now we have this x1 and y1, right? So basically, they are the coordinate of one of these values here, one of these points, P or Q. So if you plug in the coordinate of Q, for example here, using Q, yeah. Okay, so we have y minus, remember the y value of Q, it was 3, right? And then equals to 7 times x minus the value of xp, which is located at 2. Yeah. Okay, so this gives you 7x minus 14, and then this is y minus 3, and therefore we got y equals to, you see, 7x minus 14 plus 3, or 7x minus 11. So basically you get the same expression, y equals to 7x minus 11, just like what we got before. Okay, so again, in general, if you are given 2 points and then you want to get the equation of the straight line, yeah, there are many ways to do it. Yeah, you can use this general y equals to mx plus c, or you can use the slope point form, y minus 1 times equals to m times x minus x1, and at the end they will give you the same thing basically, right? So again, like I said to you before, there are many other forms of the equation on a straight line, but I don't think we need to remember all of them, yeah, because at the end of the day, basically they will give you the same thing. So as long as you know how to do it correctly, yeah, you'll be fine. And also when you put the numbers into it, all right? So in the next video, we will discuss many examples, yeah, many problems related to the equation of straight line, right? So I'll see you in the next video. Thank you.